Hi, Geo Honors. This is Miss Holden, and I'm going to do an explanation of the answers from the quarterly review, which hopefully you guys did already. If you haven't done it, then why don't you do it first and then check your answers, and then you can watch the video for the questions that you have trouble with. So you don't have to necessarily watch the whole thing. If you pretty much got everything right, you can fast forward it to the parts that you need more of an explanation on. As I said already in the weekly update, your quarterly is just going to be a little quick quiz sort of assessment. It's on Delta Math. As you already know from Delta Math, they'll show you an example of the problem before you do it. So that's going to be nice. And then the second part of it is going to be on Castle Learning. So if you do those two parts, again, it's going to count as a quiz. But if you have a low or a missing grade, then I can also use it to replace that low or missing grade. So this will help you out. All right, so here's an explanation of the answers. In question one, because the lines are parallel, that would make the angles congruent to each other because alternate interior angles are congruent. Therefore, my triangles are similar, so all I'm doing is setting up a proportion of those corresponding sides. So on the top triangle, I'm going to use the 6 and the 8. And on the bottom triangle, I'm going to use the X and the 10. So obviously the 6 and the 8 are corresponding. The 8 and the 10 also match up. And you can tell that by the angles that are there. That the 8, see how the 8 is next to this angle with the two little arcs, and the 10 is by the angle with this two little arcs, because those are alternate interior angles, so those are the sides that match up. And then all I did was cross multiply. And I get 8x equals 60 and x equals 7.5. Question 2 also has to do with similar triangles. Remember this little symbol right there means similar. I want to know which statement would justify these triangles are similar by side angle side. So that means the sides have to be in proportion and the angle between them is congruent. So AB is 6 and AC is 8. 6 over 8, that actually reduces to 3/4. And then I just went through each choice. 9 over 12 also reduces to 3/4. And they have the angle that's between them congruent. So if this is 9 and this is 12, that reduces to 3/4, and angle A is congruent to angle D. The other choices, either the sides did not reduce to the same number, or in choice 4, the sides did reduce to the same number, but they said angle C is congruent to angle F, and that would not help me because the angle has to be included between those two sides. All right, 3 is a circle problem. I have a tangent and a radius. Remember, a tangent and a radius are perpendicular, so this is a right angle right here, and I'm going to use Pythagorean theorem. So r is the radius, this is r, which makes this whole hypotenuse is actually r plus 4, so you got to be careful. So r squared plus 12 squared equals r plus 4 squared. This actually is r plus 4 times r plus 4, which becomes a trinomial r squared plus 8r plus 16. You have to FOIL to get the r squared plus 8r plus 16. And on the left, I just have r squared plus 144. The r squareds cancel, and I have 144 equals 8r plus 16. I subtract 16 to get 128, and I divide by 8, and that gives me my answer 16. Question 4 is talking about dilating a line. Remember, when I dilate a line, I get another line that's parallel. And you have to remember that parallel lines have the same slope. So I'm actually not going to do anything at all to my slope. I'm going to leave my slope alone. My slope is 3/2. So actually, I can get rid of choice 1 and choice 2 because they have the wrong slope. I'm going to take this y-intercept right here of -4, and I'm going to multiply it by the scale factor. My scale factor is 3/4, and that is my new y-intercept. So that's why my answer is choice 4. Question 5, I have a right triangle. Angle C is 90 degrees. If the cosine of B is 5 over 13, which function also equals 5 over 13? Remember that rule, sine of A equals the cosine of B if A plus B equals 90. So if the cosine of B is 5 over 13, then that means the sine of A will also be 5 over 13. 6, I have an equilateral triangle, so I drew a picture of an equilateral triangle. So all my sides were 8. Now this side on the base right here, this altitude is going to the base. It divides the base in half. That's why I just wrote 4 to the right here. The altitude is perpendicular to the base, so this is now a right triangle. And I have x squared plus 4 squared equals 8 squared. And x squared plus 16 equals 64. I'll just move this up so you guys can see it. I subtract 16 and I get x squared equals the square root of 48. And then I break this down to radical 16 times radical 3, which is 4 radical 3. And that's why I chose choice 3. Now, if you're having trouble with radicals, you can actually do radical 48 in your calculator, and it's a decimal. It equals 6.9282. And then you could take each of these answers and also convert them. Choice 3 is also 6.9282. So that's another way to do it if it is multiple choice. All right, second page I have a right triangle. This one we actually learned. You might want to turn your paper upside down. We learned the altitude to the hypotenuse of a right triangle divides it, and it makes similar triangles. This one is the leg rule. This segment right here, the X, is my leg. And remember, leg goes in the bottom left and the top right. Part of the hypotenuse goes in the top left, and the whole hypotenuse, so I have to add the 6 and the 10 together, goes in this bottom right. I cross multiply and I get x squared equals 96. And then I'm just taking the square root of 96. Now I did this one by putting it into my calculator, and it gives me 9.79. And then I just took each of these choices and did them in my calculator, and choice 4 was also 9.79. Question 8 is a median. Now remember, the median is a line drawn from the vertex to the midpoint of the opposite side. So if I'm looking here at number 8, and I think my screen froze. Let me see if I can unfreeze this so I can scroll down a little bit. And it's not. Let's see. There we go. Hold up 1 second. Oh, there we go. All right, so this is a median right here. All these are medians. Up. Now it's scrolling too much. Let me scroll back. There we go. So this median divides where they meet right there is called a centroid. Sorry, 1 sec. Okay. So where the medians meet right here at R, that's called a centroid, and it divides that median into a 2-to-1 relationship. So you can obviously see just by looking at them which one is longer, but this CR is twice as big as this RF. So basically 2 times RF, 2 times 2x minus 6 equals CR, which is 24. I distribute that 2 to everything inside, and I get 4x minus 12. I add 12, and I get 4x equals 36, and then I just divide it by 4, and I got x equals 9. Question 9 was similar to one we had on the front page. Remember the rule, sine of A equals the cosine of B if A plus B equals 90. This is my A and my B. So these equal 90. They don't equal each other. These together equal 90. So all I did was I made an equation. I added them. I set them equal to 90. 2x plus 50 equals 90. I subtract 50 and I got 40. 2x equals 40. So therefore x equals 20. Okay, so that's number 9. Number 10, those lines are parallel. Remember, when you have parallel lines that the angles are congruent, those corresponding angles are congruent, that makes those triangles similar to each other. If they're similar, their sides are in proportion. Now this might be another one that you might want to turn, because this x and this 15 right here, those I would consider the bases. And anytime you have the bases involved in a proportion, you have to make sure you're using the whole side. So basically I used the 21 and the 15, those are the sides from the smaller triangle, and then I used the 28 and the x, those are the sides from the bigger triangle. So anytime you have the base involved, you have to use the whole side. I just cross multiplied here and I got 21x equals 420. I divide by 21 and I get x is 20. Number 11 is a partitioning formula, so you should know this formula. Remember, it was x1 plus a over b, parentheses x2 minus x1, and then the same thing for the y's. y1 plus a over b, parentheses y2 minus y1. Now the problem is getting this a over b, this fraction. they gave you the ratio of the numbers or the segments. So I'm dividing this segment proportionally into a ratio of 4 to 1. If the ratio is 4 to 1, I have to make that into a fraction. That top number 4 is the numerator, but I add the numbers together to get that denominator of 5 because I have a 4 to 1 ratio. Okay, 4 to 1. So I got 4 parts and I got 1 part. So I got 4 to 1 ratio. There are 5 parts total. And then I just plug it in. -6 plus 4 over 5, parentheses, x2 minus x1, 9 minus -6. You could put this whole thing in your calculators with the parentheses and they'll give you 6. And then you do the y separately. y1 plus a over b, 4/5, parentheses, y2, which is -7, minus y1, -3. Again, you can put that whole thing into parentheses, and that's my answer. Okay, and then number 12, I have chords in a circle, and the rule for the chords in a circle, the segments of one chord multiplied equal the segments of the other chord multiplied. So the chords don't equal each other, but their segments multiplied equal the segments of the other chord. So 3 times 4, that's the segments from chord AB, equals x times x minus 4. Those are the segments from chord DC. I distribute this x squared minus 4x. 3 times 4 is 12. I notice this is a trinomial. Everything needs to be on one side, so I bring this 12 over to the other side by subtracting it. Now that I have everything on one side, I can factor it. Remember, x times x is x squared. And how did I get the numbers of -6 and 2? I say to myself, what numbers multiply to -12 and combine together to give me -4? -6 times 2 is -12. And if you're multiplying the outers and the inners, -6x and +2x give you that -4x. Once you have your factors, you set each factor equal to 0 and solve. So my answers are 6 and -2. I just reject. I don't erase this. I just put a line through it. I reject it because the length of a segment cannot be a negative number. Okay, moving on to the next page right here. Here's an equation of a circle. I want to find the center and the radius of it. The problem is it's not in standard form. So the purple is the original equation that's written right here. I sort of separated it because I need to complete the square twice. I have to complete the square for the x's. I have to complete the square for the y's. We just did this in the last chapter, so it should be pretty familiar to you. I take half of 6 is 3. 3 squared is 9. Since I'm adding 9 to the left, I have to add 9 to the right. So what I'm adding on, I did in red. I do the same thing for the y's. Half of -4 is -2. -2 squared is 4. If I add 4 to the left, I must add 4 to the right. Now, all these numbers on the right add up to 36. That's my radius squared, so my radius is 6. This trinomial now I can factor. I factor it to x plus 3 squared. And this trinomial is also a perfect square. It factors to y minus 2 squared. So my center is -3, +2. Remember, the center are the numbers next to the x and the y, but they do have that opposite sign. Right, 14 is a right triangle, and I'm trying to find the value of x to the nearest foot. So if I'm just trying to scroll down a little bit again, my computer is giving me a little bit of trouble. I'm going to use cosine on this problem because I do have adjacent and hypotenuse. Remember, SOHCAHTOA is the way that you do this, and cosine is adjacent over hypotenuse. So I'm going to do cosine of 40 equals 14, which is the adjacent, over x, which is the hypotenuse. Okay, oops. Oh, it's going to go too fast because I kept on trying to do it. Oh boy. All right, now we get to see the whole review sheet. Let's come back up to where we were. Okay, so again, anytime you have a right triangle and you're missing either a side or an angle, if you're missing a side, first see if you can use the Pythagorean theorem if you're given the other sides. If not, you're going to use trig. Whoop, and then I went right by it again. So again, I'm using cosine because I have adjacent over hypotenuse. This is my angle 40. This is adjacent. This is hypotenuse. So cosine of 40 equals 14 over x. I put a 1 under this and cross multiply. And I get cosine of 40 times x equals 14. So to get x by itself, I divide by cosine of 40. And this goes right into my calculator. 14 divided by cosine of 40. And I get 18.27, which I simplify to 18 feet. 15 is another trig problem, but on this one, we're missing the angle. So I'm trying to find the angle of angle A. I'm going to use tangent because I have opposite and adjacent. Okay, so angle A is what I'm going to call X right there. And then this is opposite and this is adjacent. So tangent of X equals 11.2 over 18.3. Now remember with trig, if you don't have the angle, if the angle is the thing that you're trying to find, that's when you're going to use that inverse button on your calculator. So I do tan -1 parentheses 11.2 divided by 18.3. And I can show you, I do have a calculator right here. And it comes up. All right, and again, make sure your calculator is in degree mode, but I hit second, and then I hit the tan button. And it was 11.3, parenthesis pops up right away, divided by, let me just see what my number was again. My number was 18.3. 18.3. You don't have to close the parentheses, but it is a good habit to get into. And then there's my angle. Okay, so let me just close this down again. So I have 31.5 because I did want to find it to the nearest tenth. Okay. 16 is another trig problem, but you didn't have a picture, so I drew myself a picture. I drew a right triangle. I'm 1/2 mile from the base of a historic monument. The angle of elevation, remember, angle of elevation goes in this bottom corner here. Angle of depression is technically outside the triangle at the top, but because they're alternate interior angles, I can also put it down here. But this is just an angle of elevation problem. Now, just be careful. This is tricky. It wants you to find the height of the monument to the nearest foot. So I'm going to take my mile and I'm going to convert it into feet right off the bat. So 1 mile is 5,280 feet. I am a 1/2 mile away, so I'm going to make that 2,640 feet. All right, so again, this is my angle of elevation. This is how far away I am. This is the monument. This is the height of that monument. I'm going to use tangent because I have opposite over adjacent. So tangent of 11.87 equals x over 2,640. I put a 1 under here, cross multiply, and all I'm doing in my calculator is tangent of 11.87 times 2,640, and that's 555 feet. Okay. Number 17 is another circle problem. It's similar to number 13 that was up above. This one just wants you to find the length of the radius, but you have to do the whole thing to find the length of the radius. You have to put it in standard form. So you can see I'm just completing the square. I took this -12 and I moved it over to the right. You basically want a clean slate on the left. All you want are the x's, the terms with the x's together, the terms with the y's together. So that -12 was brought over to the right and it became +12. Again, I leave a little gap here because I'm completing the square for the x's. 1/2 of 4 is 2. 2 squared is 4. I add 4 to the left. I add 4 to the right. Complete the square for the y's. 1/2 of -6 is -3. -3 squared is 9. I add 9 to the left. I add 9 to the right. I don't need to finish this part here because they didn't actually ask me the center, but I did finish it anyway. And on the right, I have 25. That's the radius squared. So the radius is actually the square root of 25, which is 5. Okay, number 18, I labeled my picture. Arc UT was 87. Arc RS is 21. I'm trying to find angle P. Now the rule is angle P is outside the circle. So the rule for angles that are outside the circle is it's 1/2 the difference of the arcs. Which arcs? The arcs that are included between the sides of that angle. So the 87 and the 21. It's 1/2 of parentheses 87 minus 21. And that is 1/2 of 66, which is 33. Okay. Next page. And last page, number 19 is another problem, just like 18, where eventually I'm going to figure out angle D. Angle D is outside the circle, so it's 1/2 the difference of the arcs. But before I can do that, I am missing the arc. It's 1/2 the difference of the arcs that are between that the sides of the angle. I don't have this arc of 198. So the first thing I have to do is to find that arc. They told me this arc is 84, arc EG, and arc GB is 78. Together, all three of the arcs equal 360. So all I did was 360 minus 84 minus 78. That's how I find that missing arc of 198. Now, once I have that arc, I can do part B. Part B wants me to find angle D, which is outside the circle. It's 1/2 the difference of the arcs. The arcs that, it's always the bigger arc minus the smaller arc, and it's the arcs that are included between the sides of that angle. And that comes out to be 60 degrees. Number 20, I have an angle 125 is angle DGF. Now that's not a central angle, and the rule for an angle that's not a central angle or an inscribed angle, if it's inside the circle, it's 1/2 the sum of the arcs. This one is different though because I actually know the angle. The arcs are the things that I'm trying to find right here. So I know that arc AE is X, and arc DF is going to be X plus 56 because it's 56 more than the measure of arc AE. And again, the rule is the angle, which is 125, equals 1/2 the sum of the arcs. So I'm adding those arcs together. The first thing I need to do is to get rid of this 1/2. So I multiply by 2 and it's gone. And I multiply this side by 2. That's how I get the 250 right here. Then I subtract 56. I divide by 2, and X is 96. Okay, so that's my answer. And my last question, 21, is a trapezoid. So I have an altitude. The altitudes are 12. The side CD is going to be 13. And that makes this side also AB 13. Both those sides are 13. And I know this is 12. The first thing they want me to do is to find the perimeter of the trapezoid. I can't find the perimeter unless I don't have this side right here. I know this top base is 15. That makes FE right here also 15, but I don't have these little side pieces, the AF and I'm not sure what letter this is over there, ED, there's a D right there. So, but this is a right triangle right here, so I don't have this 5. I figured this 5 out. In order to find AF, I'm going to use the Pythagorean theorem, so I just called AF X. X squared plus 12 squared equals 13 squared. X squared plus 144 equals 169. X squared equals 25. Therefore, AF is 5. Now, if this is 5, this over here is also going to be 5. Now I can find the perimeter. I'm just adding 13 plus 15 plus 13. And this whole bottom piece right here, 5 plus 15 plus 5 is 25. That perimeter comes out to be, I didn't add all those up. Okay, but you guys can add them all up. I'll make sure that it's posted right there. What is this? 25 and 15 is 40, and 40 and 26 is 66. So that should be 66. All right, and the last question, we're going to have to use a little trig. I'm trying to find angle BCD. Now, BCD is this whole angle up here. This part's 90. What I don't have is this part right here, angle ECD. So I'm going to call angle ECD right here where my cursor is X. And so I'm going to use sine because 5 is opposite and 13 is hypotenuse. So to find that angle, sine of X equals 5 over 13. Remember, when you don't have the angle, you're going to do that inverse. So X equals sine -1, 5 over 13, which is 22.6. And then to find BCD, BCD is 90 degrees plus angle ECD. So 90 plus 22.6 is 112.6. Okay, so again, your quarterly is just a little quiz classwork grade. It is 2 parts. One part is on Delta Math. And as we know that's nice and easy Delta Math because they show you an example. If you want to, click on Show Example before you do the problem so you can see a similar problem with different numbers. And then the second part is on Castle Learning. You can use this review sheet, you can use your notes, and you're going to be working on that on Friday and Monday. Okay, and then we're going to start our next chapter, which is dealing with area and volume. All right, great. Let me just turn this off.